the customer had a lightning strike recently and had the converter replaced, and then found out the control board for the Dometic Refrigerator was burned up. And now they've got a replacement board that they have picked up from a local dealership, and they're asking us to put it in for them. Well, first thing we're going to do is verify that we got 12 volts to the refrigerator. So right here is where our DC voltage arrives. Solid white almost always is our negative, or ground as some people call it. So let's see what we got here. The meter says we got 13.2, so we know the power converter is working because batteries don't put out 13.2 volts. So we've got our DC, got our 12 volts. Let's see what we can figure out here. Here's our heating element, or heater as Norcold calls them. All right, so here we got black wire is screwed into the metal, which tells me that's a ground, and it's just 2 wires running up. Here we've got a wire harness that's got a home, another wire harness that's got a home. This guy here is more than likely going to be the light inside for the refrigerator. These guys got a home, and then down here, what do we got going on down here? This is a thermocouple. Okay, this board is supposed to be a universal board. We're going to find out how universal it really is. Okay, so this black and this white right here, you can see this cord plugged into the wall, right? Well, here's our black and white. So this is going to be hot AC voltage. This is the neutral for AC voltage, and then the green wire is just screwed into the metal as it should be. So we can go ahead and set our meter on AC voltage, and we can touch our probes into this guy, and we can just touch metal, and there's 123 volts live on this. So these two guys right here are what run the heater, the electric heater. All right, so what we need to do now is figure out on this control board where everybody's home is supposed to be. In the meantime, I'm going to unplug this so I don't get bit, because I don't like getting bit. All right, let me get my reading glasses. Now, the wife ran off with my reading glasses out of the truck and left hers behind, so I don't need any comments about my bedazzled reading glasses. Okay, we got lamp, heater. This guy here is going to be the light for the inside. We're going to plug him into the lamp. We've got flame, AC line. That's AC line, AC neutral, AC heater, ground, AC heater, flame. Okay, so basically the only thing we don't know goes where is our thermocouple. I may need to consult the little Dometic book here and hopefully find out how they want those plugged in. So let's get the little handy dandy Dometic book. Oh, AC heater. Just occurred to me. These companies, they call heating elements heaters. They call control boards power boards. Just don't call them the same thing that I would call them. Okay, so there's no polarity issues with these. It's just, as you can see, 2 black wires. It don't matter, but they both have to be on a tab that says heater, because the control board will send our voltage to this guy, and it will get hot and make the boil inside the boiler that we need to make the cold. And it could just be that. Could just be. I've got a feeling this will probably go on neutral. So one wire of the thermocouple. Now thermocouple is my question, and that's F. And we got F, it goes to J10. J10 is empty, but we will put thermocouple on J10. And the other end of the thermocouple, wow, looks like it just goes to ground. So apparently on the old control board, there was 2 tabs for thermocouple, but on the new board, that just needs to go to ground. So we need to somehow probably cut that end off, put a ring terminal on it, and put him right there under that screw. But in the meantime, let's make sure we got everything else right. Reading this. Here's 2 from thermocouple F. 2. The other end goes to J4. So we don't cut that. Scratch that from the video. We don't cut that. We don't put a ring terminal on that. That goes right here to J4. Yep. And then J5. Okay, so that should be wired properly. So now we should be able to go ahead and plug this guy in. And we should be able to go inside now and see if the control is active. And of course, when you're working on these absorption refrigerators, this is a sealed system, and it uses heat to make the cold. So inside this system is ammonia, hydrogen, water, sodium chromate. That mixture, when it's boiled in the boiler, the vapor from that boil is like minus 40 degrees. It's super cold. So that vapor goes to the top, works its way down, and it's a cycle, it's a process of vapor, liquid, vapor, liquid. And anyway, at the end of the line is this collection tank here. And then it'll make its way through here, back down to the boiler to get boiled again. That's how it makes cold. But sodium chromate is yellow powder. Sodium chromate will be the telltale sign if there's a rupture in the boiler. So when I show up on the job and they're just like, the fridge just don't cool anymore, and if I take that cover off and I see any yellow powder right here, any yellow powder, this cooling unit has to be replaced, and there's no saving it. But I don't see that here. But all this does, much to a lot of people think that this does way more than it actually does. All this does is provide AC voltage for the heater. Gotcha. That's it. It goes into the board. It has the fuse for it, and that board has a drawbridge. Turn on, turn off. That's all it does. It's the burner side is all 12 volt. That thing runs on 12 volt. The 12 volt is actually the more important of the two. So you could actually leave that unplugged and still have a working refrigerator. So let's go inside and see if we can get a refrigerator to work.
But he just does big air conditioners.
All right, well, let's go outside and verify. We may have a situation where the eyebrow board was damaged in the lightning strike. Yeah, we got our AC voltage there.
Oh my goodness.
There we go, 13.2, 13. No, we have a blown fuse. So that would explain why we have nothing going on inside. So if you swing the camera around here, you'll see where my finger's pointing. Little glass fuse right there. All right, so let's change that guy out and see what we've got going on. Here we go. Here we go. So somewhere in there used to be a filament, and there is not one there now. So we can go to our handy dandy voltmeter here, go up here to continuity, and so when the voltmeter sends, you know, just a little current through the probe, and when that current reaches the other probe, it beeps, right? So if the fuse is a good fuse, then it should beep. And the fuse is not a good fuse. So now the question is does old Link have a short in stature fuse? And let's see, what are we looking at? A 3 amp. So we have a good fuse. Okay. All right, so we got a new fuse in it. We're gonna plug our eyebrow board in. Okay. The fuse is still intact. All right, so let's go inside. Oh, it's a good sound. Plug that in, and then we should hear it click off over to electric. I just heard it click. Might have been hard to hear over the boots and the gravel.
Yeah. I didn't hear it, but I guess you heard it.
What I had happen here was I heard the control board click, I heard the igniter tick, but it only ticked 2 times. And then usually when you hear the ticking stop, it's because there's a flame. There's no flame in there. A little bit of gas, but there's no flame in there. So I'm not sure what's going on with all of this. Not sure if she even uses the gas side of this. But we're going to go inside. Well, we already know that it's clicked over to electric. So what we can do now is check the amp draw on the heating element and see, do we have heaters heating up? And there is nothing on that wire. And usually when there's nothing there, there'd be nothing on the other one. Nothing there. So that heating element is drawing nothing. So what we're going to do is see, is the control board even putting 120 volts to the heating element? 124 volts. Okay. So we know that heating element is getting its voltage. I guess the question now is does the heating element, is it burned out? If it's burned out, then the way we can find out, let's unplug this guy. And we're going to check the ohms of the heating element. Now this should click and try to light. Alright, so let's take that off. Whenever you're doing your ohms tests, all the wires are to be unplugged and disconnected. So we know that we've got the 2 wires to the heater. Okay, and we're going to stick our probes in there and see what kind of ohm reading they have. Okay, so this is chilling out. Okay, that right there, just from experience, tells me that that heating element is fried. So she's going to need a heating element. All right, to get this guy out, you got this safety sheet metal around, and it's got a little tab right here. That is our heating element. All right, so now that we got that out, what we should be able to do is find the stamp on it, which tells us how many watts it is. And usually they stamp it in the metal. There we go. This is 325 watts. Okay, so at 115 volts, 325 watts. So now, I can't do it because you're holding the phone. I have a handy dandy app that'll calculate what the ohm reading should be. So after running the information we learned about this heating element through my calculator, we have a 325 watt element and 115 volts. So the ohm should be 40.69. And I think we saw 24.67. So that would tell me that it is like way out of parameter. And normally, when you're doing an ohms test on a heating element, it just goes relatively quick right to what the resistance is. It doesn't do the slow climb like this, which again tells me that I think the heating element is the problem. 325 watts. So if that will fit in there, then we may be golden with this. All right, it's still counting. Still counting resistance. Holy cow. I don't know that I've ever seen a heating element do that before. Cleaning some debris off it. Since I don't have a brand new heating element to get her going, we could use a used one. And if she would like a brand new one, we can certainly get her one. But more often than not, people are happy with a used one. So let's put that guy in. Sometimes you actually have to shove the fridge halfway out of its hole to be able to do this, but we are having great luck, I think. Getting them out tend to be a little bit easier sometimes. Sometimes it helps to be able to twist it as you're pushing down. And I don't really have the clearance to do that. Boom. Heater's in. Okay, so now I'll fish these guys around. back into J7 and J8. All right. Now when we plug this in, we should find that this is getting hot and there's some kind of amp draw on those wires. Amp draw. It may be zeros at the moment. Oh, there we go. 275. All right. Yeah, getting that little sheet metal flat back on there can be a real pain in the butt, because you want to mash that tab over and it wants to deform everything while you do it. But victory is mine. Okay. It is not getting hot quick, that's for sure. But it is definitely heating up. So as you can see on here, they've got these little cavities here. You know, you can run wires out the side of it, you know, so like these wires that are going into the cabinet of the refrigerator, you know, we could run them out this way if we wanted to. These wires here, we can run out to the side if we wanted to. In fact, I may just do that for these wires. But if all the wires will fit, you got this big opening in the bottom, you know. So. Make sure nothing's all pinched up and unhappy, but everything looks happy. Now, on these Dometic refrigerators, there's supposed to be a plug on that. And the Dometic folks have nicknamed it a bug plug. Yeah, that's getting very hot to the touch, so this refrigerator should be good to go. Obviously, as the nickname says, it keeps bugs out of the refrigerator, but it also keeps humidity at bay too. So humidity is not chimneying up into the refrigerator and causing a big frost up issue. Bug plug. And since we're here, and since ventilation is so crucial and important to the operation of the refrigerator, I'm gonna look up there and make sure that the vent on the roof is clear and open. Sometimes insulation falls over the condenser. The refrigerator ain't gonna cool well.
You want anything to drink? Or?
Okay, we're all clear on the top.
No, you don't, man. You don't drink.
All clear up top.
Week on Saturday.
Put a little bug plug in there. And this refrigerator is right.
Yeah, I probably do. If Brandon
It just goes out the hole. All right, we're locked in. Vent is in. She should be good to go. Okay, so the check light was on, but usually, almost always, check light just means you're out of gas. There's no flame. So you turn it off, turn it back on, it eliminates your air. And since this thing's running on electric, if this button was out, as the profile shows, then that would be on gas mode. But since it's in, it's on auto mode, which is always electric first.